The brief part of Chapter 8 is going to let us look at functions that have more than two variables. Basically, we're going to go to a three-dimensional concept. We have been looking at functions in just the xy plane. Now we're going to look at x, y, and z. So first of all, we need to look to see how we can evaluate these functions. What are those functions going to look like? And then we're going to talk about what is a level curve. So a function of two variables has a different domain. Instead of a domain of just x, it has a domain of x and y. And z will be the dependent variable. So x and y is going to determine our value of z. This looks really pretty cool. Not that we're going to graph any of these, but I wanted to show you some of these pictures that you have an xy plane, and then you have this z that's perpendicular to it. And so that's how we get three dimensionals, which is much more like real life. Now don't panic, this is actually going to be very easy. So let's just look and see how you would evaluate a function. Just like you learned how to evaluate an f of x, now we're going to learn to evaluate f of xy. In this case, it's the function is in terms of g. So we're going to have g of 1, 2. This is x, this is y. It just means where there is an x, you're going to plug in 1, and where there is a y, you're going to plug in 2. Very easy arithmetic. Right? If I want to evaluate g of 2, 1, now this time x is 2 and y is 1. And you can see that those are two different values. So when you switch the x and y, you don't get the same answer. All right, let's just do one more. G of 1, 1. X is 1 and y is 1. Just very nice, easy arithmetic. All right, this time we have h of xy is defined by x plus y divided by x minus y. So if I wanted to evaluate it at h of 0, 1, x is going to be 0, y is 1. Again, just plugging in numbers. But what is this h of pi and negative pi? Well, again, this is x, this is y. So we have pi minus pi on top of pi minus a negative pi. So that's 0 over 2 pi, which is 0. They're just trying to make a point that all these values are, this is x, this is y. You plug them in the appropriate places. Now, this is really going to add a fourth dimension, which is kind of weird. But again, it's just practice on evaluating such functions. So we're going to evaluate this function at 1, 2, and 3. So in this case, this is going to be u, v, and w. All right, here is our function. Wow. All right, so let's see. We have u. I'm just rewriting this. And that's all divided by u squared plus v squared plus w squared. All right, so everywhere there's a u, we're going to put in a 1. So here, here. All right, then v is 2, w is 3. So looks really weird, but it's very easy. So we have, remember, we can multiply those exponents. And let's see, that's going to be 1 plus 4 is 5 plus 9 is 14. All right, again, just practice on evaluating those functions. It looks weird, very easy. So let's talk about what these level curves are. Since it's very difficult for us to graph three-dimensional space on top of a two-dimensional paper, what we can look at is what would happen if we took this three-dimensional object here and project it down into the xy plane. And that is going to be called the level curve. So hopefully you can see this cross section here is projected here, and we get this oval looking type thing for that particular three-dimensional object. Kind of comes in handy on like contour maps and things like that. Perhaps you have seen a map of the United States where it's contoured so you can see like the actual mountains and things like that. And so if they were projected down and you saw a contour map, it would look something like this. So you could kind of see what the altitude of those mountain levels are. So a level curve is a function of two variables with the equation f of xy equals to k, where k is a constant. All right, so each little shape here is a different k. Sounds difficult, but it's really pretty easy. So if we take this function and I want to graph it with these being the different z, you're just going to take this function and let it equal to each of those values and graph. But before we graph, it might be easier perhaps to solve for y. So I'm going to take here and say y is going to be positive x squared minus 2. This one's going to be y equals positive x squared minus 1. And hopefully you remember from college algebra that those are quadratics, they're parabolas that are shifted down 2 units. So you could make a table of values, but remember this is y equals x squared, and this minus 2 is going to shift it down here. So this would be when k equals to negative 2. All right, then at negative 1, if you have at 0, you're going to get this one. And then if you have 1, it's going to be shifted up. And hopefully you're getting the idea. All right, that's all it is. It's easier if you can solve for a y, because that's what we're used to graphing in terms of. All right, and the last thing you're going to be asked to do is find the equation of the level curve that contains a particular point. So this is x and this is y. Now let's go back to that definition of the level curve, that this is going to be equal to some constant. So we just need to find k. How do we do that? Well, let's evaluate the function at negative 1, 2. So f of negative 1, 2 is equal to 4. That is going to be k. So my equation of my level curve is going to be negative 2x squared plus 3y is equal to 4. This is probably one of the easiest sections we've covered yet, so take advantage of it.